Hey guys, welcome back. So we're looking at 2.2 today, falling off a log. So logs are a kind of mathematical function that we're going to be looking into a great deal here. So solving simple logarithmic equations, find the answer to each logarithmic equation, explain how each equation supports the statement. The answer to a logarithmic equation is always the exponent. So we have log base 5 of 625 equals what? Now, what that statement, the answer to a logarithmic equation is always the exponent. If 5 is our base, to what power do we need to take 5 to get 625? Well, we need to take it to the fourth power. Number 6, log base x of x to the 7th is what? Well, it's already giving us the final answer. We have the base of x. It's telling us after we take it to some exponent, it's going to be x to the 7th power, and our answer is always the exponent, so it would be 7. Now, on number 5, it's log of 1 million. Now, log is, if there's no base term on it, log is always base 10. We just never write the 10 when it's base 10. So if this is log base 10 of 1 million, how many zeros are there? 6. So that means it's 10 to the 6th power. So that means our answer is 6. So you're just looking to take and see what the exponent should be. So what for each of your base numbers, to what exponent should you take it to get the big number? So number 2, what do you have to take 3 to get 243? Number 3, what do you have to take 5 to get 0.2? Hint, if you get a decimal, it means you're taking it to a negative exponent. For number 4, what do you have to take 9 to get 81? So that's what you're looking at here. All right, number 7, answer questions about each graph. So what is the value of x when f of x equals 0? So when our y value is 0, what is our x value? Well, that means we're on the x-axis. Where it crosses the x-axis is 1. What's the value of x when f of x equals 1? So here's f of x equals 1. We go over. We're at 2. What's the value of f of x when x equals 2? X equals 2. Value of f of x is 1. What will be the value of x when f of x equals 4? So we're 1, 2, 3, 4. Extending it out. Notice we're not quite there yet, and we're at 1, 2, 3, 4, 5, 6, 7, 8, 9, and we're still not quite to it. But based on what we're looking at here, if our first term is at 0, our second term is at 1, then we're looking at taking each value. So 4 would get us to 16. So the equation for this graph would be y equals log base 2 of x. So when we take 2 to the first power, we get 2. When we take 2 to the 0 power, we get 1. When we take 2 to the 4th power, we're going to get 16. So there is what we're looking at. So you guys will do the same thing for number 8. All right. For number 9, use the graph and the table of the values for the graph to write the equation of the graph. Explain which numbers in the table helped you the most to write the equation. So for this one, I'm actually going to do both of these with you guys because they're a little confusing. So for this first one, we have our graph and we have our table of values. So we've got 1 is at negative 2, 2 is at negative 1.369, 3 is at negative 1, 5 is at negative 0.535, 7 is at negative 0.2288, and 9 is at 0. So for this one's a very tricky one. But if we notice where it is, we're down further than what we usually are. So it's crossing way lower. So we're actually shifted down 2. because our 1 value is at -2. So that's where we see that. So we're going to have log base something of x minus 2. Now, what our base is we actually have a base of 3. So when we plug in 3 to this, so we'd have 3 to the third, but we're subtracting the 2, so that's how we end up with the -1 instead. All right, for 10. In this one, we have error for -2. Anytime you get an error, that means that you're getting a 0 for your answer, so for the big number in the log, and we can't ever have that. So that must mean that we have an x plus 2 inside those parentheses on our log, because then plugging a -2 into there would make that a 0, so it doesn't work. All right, so then log, we need to figure out the base. Well, the base is going to be, so if we plug in a 1 here, that'd be 3. So our answer is 3. Our y value is 1. So that must mean that it's a log base 3. Because we got 1 when we plugged a 1 in here, and 3 to what power gives us 3? Well, that is 1. So there is our equation. I guess I should include the y equals. All right, using the power to a power rule with exponents to simplify each expression, answers should only have positive exponents. So for these, every single one of these, you are going to multiply your exponents together. And some of them you may have to do some adding too, but most of them are all going to be multiplying. So for 11, we have 2 to the third to the fourth. We multiply 3 and 4, so we have 2 to the 12th. For 13, we have a to the third to the -2nd. So this gives us 3 times -2 is -6, but we don't want negatives, so it's 1 over a to the 6th. 14, we have 2 to the third, w to the first, all to the 4th power. So we're going to have 2 to the 12th, w to the 4th. We just multiply. All right, on 17, we have x squared times x to the 5th squared. So we multiply on these two, so x to the 5th, so 5 times 2 is 10. So now we have x squared times x to the 10th. Now we add these exponents, so 2 plus 10 is 12. So remember, if you're multiplying two base numbers together that have exponents, you're going to add the exponents together. If you're taking one number with an exponent to another exponent, that's when you multiply them together. On 16, d to the -3rd to the -2nd, -3 times -2 is +6. Oh, some of these, it'll cancel out that variable for you. Okay. All right, so that's what you're doing on there. So your keyword for this lesson is exponent. Exponent is your keyword for this lesson. If you guys have any questions, feel free to ask. Have a great day. Bye, guys.